I was going to go over this first example in section 10.2 hyperbola is a graphing problem, but I also want to show you how it looks in ALEKS. So I'm going to change my problem to this one that I just found. I opened your homework and this was the first topic. Let me change this to y plus 3 over 25. I'm just trying to rewrite the problem so that I can show you how graphing looks like in ALEKS. And then I have what? X minus 2 over 16. So I'm dumping my original example so that I can do this one. Okay, so let us start. Step number 1, when you are graphing a hyperbola, you start by plotting the center. So step 1, find center. Let's see. What is a number being subtracted from x? Well, as you can see, we have x minus 2 right there. So the x coordinate of the center is going to be positive 2, always the opposite. Now, what's the number being subtracted from y? Well, we see y plus 3. So I'm going to change that to y, coordinate of negative 3. So just go with the opposite of what you see. Okay, that's how you find the center. Go ahead and plot that first. Click. All right, let me try. So on this paper, I'll go 2 to the right, down 3. 2 to the right, down 3. Here is my center. I'll do the same thing on ALEKS, okay? So I'll pick up this pencil and I'll plot 2 to the right, down 3. Oh no, I messed it up. 2 to the right, down 3. That looks good. All right, next point. Guys, you just need to plot 3 points really. Number 2, we are going to plot the vertex. Plot the vertex. Now listen, to find the vertex, find a bigger number in the denominator. What's the bigger number out of 25 or 16? 25 is bigger, right? So 25 tells us how many we need to go up or down to plot the vertex. Now, why do you think I'm saying up or down instead of right or left? Now, this number 25 is the denominator for the fraction for y. So because this is under y, I know I'm going to be going up. First of all, you know 25 can be written as 5 squared, right? So to plot the vertex, I will be going up 5 and down 5 from the center, okay? So let me go down here to find the vertex. Go up 5 or go down 5 from the center. So look, we're not going to the right or left at all, okay? So the x coordinate of the center will be the same. It's going to be still 2 and 2. But because we go up 5 from the center of the y value of negative 3, this first one, let me do negative 3 plus 5. And we will get 2 as the first vertex. But I can also go down 5 from negative 3, right? So if you go down 5 from negative 3, you're down at negative 8. So plot those two vertices, okay? So one at 2, 2. And the other one down at 2, negative 8. Now, on ALEKS, you don't really need to plot both, but I will do both, okay? So getting my pencil, getting plotting 2, 2 first. And then go down and plot 2, negative 8. Done. Now, the last thing you're going to plot is the point that is on the asymptote. Okay, now that one's a little bit tricky. But listen, didn't we just use the 25 to go up 5, right? Now look, we're going to use the other number now, okay? That smaller number of 16, we're going to take square root. And when we can write 16 as 4 squared, that tells us how many we are going to the right or left. Now watch this. I am going to write from this vertex, okay? So step number 3 right here, what am I doing? I am plotting a point on asymptote. So from that vertex, go right 4 and plot a dot. I'm going to go 1, 2, 3, 4 and plot a dot. Do the same thing all around the center. Okay, watch. I'm going to go left 4. 1, 2, 3, 4 and plot a dot. I'm going to go to the other vertex and do the same thing. Go 1, 2, 3, 4, plot a dot. And 1, 2, 3, 4, plot a dot. Now we have this rectangular pattern. Let me sketch the asymptotes here for you, okay? So using a dotted line tool, I'm going to sketch an asymptote. The first, oh, that's a mess right here. Give me 1 second. Let me do this line first. So there's that first asymptote. Okay, and let me do the other asymptote. See guys, when I have to do this on my paper, I have to do it myself. But when you do this on ALEKS, they kind of graph the asymptote for you automatically, so that makes it a little easier, okay? Now, after that, all I gotta do is just go back to that vertex, and sketch a hyperbola, getting really close to those asymptotes. And that's all you have to do. Place another one going downward. Now, what does it look like in ALEKS though? Let me show you. Let me finish this up then, okay? All right, so over here, I'm gonna do the same thing. Get a pencil. So from the vertex, I'm going to go 4 to the right. 1, 2, 3, 4, plot. And that's really all you need. So, all right, hold up. Let me even erase this one. So all you need to plot when you are trying to do this on ALEKS homework is the center, the very first center right there. The vertex, one of the vertex, and one of the point that will be on the asymptote. Now, once you have those 3 points, click on the hyperbola tool, okay? And they're gonna ask you to place the center. Where's the center at? This point right there at 2, -3. Next thing they're asking is placing vertex. Now go up, move your mouse, put that vertex right there. And then lastly, they want you to place the asymptote point. So I'm gonna move this mouse and click on that circle right there. That's all. And voila, look at that. Looks the same as what we have here, right? So practice this. I'm gonna click on check. And that is how you can graph a hyperbola, okay? Either by hand, okay? Center vertex, plot a point on the asymptote, and also using the tools in ALEKS, okay?